We do hope that everyone that are present in this matter are safe and healthy. As much as we wish a peaceful day for everyone through this current crisis we are facing, especially to our chairman of the panel, Engineer Maria Lourdes V. Balansay, and to our panels, Engineer Jeffrey Sarmiento and Engineer Annalyn A. Cueto, and to our advisor, Engineer Rosalyn Hernandez. Again, we do hope that everyone are present as we are glad to present to you once again our study entitled as Diagnostic Software for Electric Motors at Calao Agro-Industrial Corporation or CAIC FEDMIL. By the way, I am Moaimin Samporna presenting to you our Chapter 1. Going on for introduction, in all cases, maintenance plays an important role in industry, especially in production. A failure in maintenance is also a failure of production or operation, meaning without a good and proper implementation of maintenance will result to a malfunction of operation or worst would lead into a motor shutdown. In modern plant operations, unscheduled stoppages and of productions or long repair shutdowns are intolerable. The high cost of the resultant downtime costs deeply into profits. Among the 4 M's of the production, which are the machine, method, manpower, and material, the highest contributing factor to downtime of the company is the machine. Now, the company started its operation in 1999. Since then, the motors are repaired only if failure occurs. One of the major reasons is that it is too costly. As much as possible, the company wants lower expenses, thus, they minimize their operation and maintenance cost. Considering the problems that we were mentioned, the researchers decided to conduct an evaluation of the existing equipment at Calao Agro-Industrial Corporation, or CAIC FEDMIL. Has proposed a diagnostic software for electric motors in which its function is to provide maintenance plan for the feed mill. Also, it could give possible solutions to the problems in terms of guidelines for the motor troubleshooting. In addition to this, it will serve as a handy tool to the maintenance personnel conducting a regular maintenance activities. Furthermore, this could maintain and prolong the life of the motors, which will eventually lead to a better production and savings. Now, let's proceed for our objectives for our study. First, the researcher will have to evaluate the profile of the electric motors in Calao Agro-Industrial Corporation feed mill in terms of its types of motors, specification of motors, date of its purchase, date of installation, and date of operation. Second, the researcher will have to develop a diagnostic system software considering the following design. First is software design, which includes the database designs as well as the algorithm. Next are those standards in compliance to the following organizations such as the IEC or International Electrotechnical Commission, Philippine Electrical Code or PEC, and the National Electrical Manufacturers Association or the NEMA. Also, the researcher include those factors that affect the conditions of motor. This includes the electrical factors, mechanical factors, as well as the environmental factors. And of course, for the effective maintenance program for the motors, the researcher provided a corrective maintenance such as the motor troubleshooting, and for the scheduled maintenance, which has to be the preventive maintenance and the predictive maintenance. For our scope and delimitation, since everyone are affected in this crisis, the researcher will record and will register the existing equipment of the feed mill into the system, and the researcher will propose maintenance plan program such as the corrective maintenance and scheduled maintenance for electric motors. This includes the motor daily walk-around checklist, condition-based or predictive maintenance and preventive maintenance, as well as troubleshooting guidelines manual that is essential for the maintenance plan program. Lastly, for the second significance of our study is still the design of the diagnostic software for for the electric motors could benefit the following. First of all, the Calao Agro Industrial Corporation or the CAIC feed mill. The software could benefit the Calao Agro Industrial Corporation CAIC feed mill due to the absence of its maintenance in their production. This study would help them for easier implementation of the maintenance that they needed. And for the Batangas State University, this study would provide valuable information to the students of the Batangas State University, especially to, to the electrical engineering students and mechanical engineering students. The students could use this study for the future research and inventions. Also, the electrical engineering department will benefit for this study. The project could serve as a worthy contribution to the achievement of the electrical engineering department of the university. The department would be acknowledged for producing relevant research studies, as well as the study will be benefited by the electrical engineering students, in which they can study the learning paradigm to enhance the students' knowledge and skills by using this study as reference or guide. Lastly, for the future researchers, they could benefit this study in a way that the application of the knowledge and skills that they have learned in the field of electrical engineering, it will augment the knowledge by applying related theories and principles gained from the previous studies. Thank you.
Good day to our panel and to our advisor. I am Mary Jane A. Maligas presenting to you our Chapter 4. This chapter presents the analysis of results, planning and development of the diagnostic software for electric motors and the diagnosis made by the software in terms of its functionality. 4.1 is about the evaluation of the motors being used by Calao Agro Industrial Corporation or CAIC feed mill. Layout of the machines and specifications are determined to assess the motors present in Calao Agro Industrial Corporation feed mill. Layout of the machines is shown in figure 4.1, while the specifications of the motors used in the company is shown in table 4.1. Calao Agro Industrial Corporation or CAIC feed mill is composed of 12 alternating current motors and are all induction motor type. The motors are ranging from 1.5 horsepower to 50 horsepower that performs the complete operation of the feed mill. One of the primary motors of the plant is the hammer mill, which is a 3-phase 50 horsepower motor that is responsible on grinding different types of grains, and it quickly reduces bulk grains to smaller pieces by repeated blows of hammers for further processing. Another one is a 30 horsepower mixer that mixes all the necessary ingredients to achieve the finished product. The feed mill has a pumping section in which the motors are responsible on pumping the oils and molasses by means of compressor assembly. The feed mill has a separate assembly of micromixers that mixes the medicines needed for the poultry animals. The operation has blowing section that separates the dust and bushels of the grains from the cycle of operation. Another is the elevator section, which brings the grains into the hammer mill for grinding, and the conveyor, which delivers all the ingredients into the mixing section before proceeding into the final process, which is bagging. The motors present in the feed mill are the following. First is the hammer mill, which is a 50 horsepower. Next is a mixer, which is 30 horsepower. Blower, 5 horsepower. The bucket elevator, molasses pump, oil pump, micromixer, and the bin are 30 horsepower, and the sieve, which is 1.5 horsepower. The ratings of each motor, such as its voltage and ampere, is used in the system for profiling purposes. 4.2 is about the software design and development. The designing and development of the diagnostic software for electric motors, considering its system requirements, shall be discussed in this section. For software requirements, first is the flowcharts. Flowchart serves as the basis of the proponents in developing the system software. It was a visual representation of the databases and their relationship with each other. First flowchart is about the system development flowchart. Figure 4.2 shows the system development flowchart of the diagnostic software for electric motors. As a start, a requirement analysis is done where all the desired functions of each component in the software was analyzed. After analyzing, the design of the system was established to distinguish where the codes will be encoded. In encoding, all the system functions equivalent codes will be entered to develop the software. Test executions were done after the coding to test whether the system's functionality is failed or not. If failed, the trouble would be analyzed and corrected until the desired functionality was met. Figure 4.3 shows the login flowchart of the software. For the login system, a login window was provided. If the user doesn't have any account on the system, a sign-up window is provided for registration. If the user was already registered, a username and a password was needed to proceed. If the information was invalid, the system will show an invalid input notification and will redirect the user to the login window. While if the information was valid, the system will enable you to access the main window. Figure 4.4 is a sign-up flowchart. A sign-up window was provided which allows users' information to be registered. Username and password were the only requirement for the registration. Upon signing up, the system will direct the user to the login window. Figure 4.5 is about the Show Profile flowchart. Show Profile flowchart starts with the motor selection panel wherein the user will select the type of motor either by using the drop-down menu or by typing the motor code into the motor code text box. Once the user selected a certain motor, the system will enable the main tab panel where the profile of the motor is located. Figure 4.6 is the Show History flowchart. In the figure, showing the history starts with the main tab panel. The user will select the History tab located in this panel. The user will input the period when the maintenance needed was done and select the maintenance type that the user wants to view. The user can click the View button to show the motor history displayed as a PDF file. Figure 4.7 is about the Update Maintenance flowchart. Updating the scheduled maintenance of the motors is also located on the main tab panel. The user will select the Scheduled Maintenance tab and two tabs will be displayed. The user will select either the maintenance to be done was a preventive or predictive maintenance. Selecting either needs a fill up on the provided maintenance checklist, and by clicking the Update button, the system will record and update the maintenance done. The user may also print out the checklist under this tab by just clicking the Print button. This will serve as the guideline of the user in doing the maintenance proper. Figure 4.8 is about the Update Troubleshoot flowchart. In the main tab panel, the Troubleshoot tab was also located. Selecting this tab will direct the user to two tabs, the Manual and the Update tab. The user will select the Update tab and fill up the informations done in troubleshooting the motor. Once the informations were complete, the user will click on the Update button for the system to record and update the corrective maintenance done on the motor. If ever the user needs a manual as guidelines for the troubleshooting, he can go to the Manual tab and select the type of trouble to be printed, which comes with its corrective action plan. Figure 4.9 shows the notification flowchart. The system has three notifications, namely Reminder, Due Today, and Alert, which are all located on the notification panel. This flowchart loops every 30 seconds for update purposes. First notification was the date before the maintenance schedule, which will show the motor's notification on the Reminders panel. Second notification was the specific date of the scheduled maintenance, which if not yet updated, will display the motor's notification on the Due Today panel. Third notification is about the date after the scheduled maintenance, wherein if the user does not update the maintenance on the scheduled date, the notification will show on the Alert panel. In the Alert panel, The daily maintenance will always show unless the user updates the checklist for that day. Figure 4.10 is the Add Motor flow chart. Adding a motor was located on the motor selection panel. There is an Add Motor button where the user can click to register a motor. A motor registration window will be displayed where the user needs to fill up all the information about the motor. Once the information was complete, the user can already add the motor by clicking the Add button. Figure 4.11 is the Edit Motor flow chart. Editing the motor's information was also located on the motor selection panel. The user will select the motor to be edited and the Edit button will be enabled. Clicking this button, an Edit Motor data window will display where the user can alter the information of the motor. After editing, an Edit button can be clicked to be updated into the system. Figure 4.12 is the Delete Motor flow chart. In deleting a motor, the user will select a motor from the motor selection panel where the desired motor to be deleted will be chosen. After the motor has been selected, the user can now be able to access the Delete button, which when clicked will show a confirmation message asking if the user really wants to delete the motor. If yes, all the motor's information would be deleted. Next is the programming language. The proponents use Visual Basic since this programming language has basic functions and commands that let the proponents simply drag and drop the objects and define its behavior and appearance. Furthermore, there are methods that the proponents followed to establish a working system, and these are presented herein. First is the preparation of data. The manuals needed for the maintenance were gathered from other related studies and internet sources. Second is the software development. The software has different forms which was distributed within the proponents. The forms include the registration, profile, history, scheduled maintenance, the preventive and predictive, and the troubleshoot. Third is the integration of data. The developed forms were integrated to establish a working system software. Lastly is the testing and simulation. The proponents undergo several testing and simulation of the software to identify the troubles and to finalize the functionality of the system. Next is the GUI, or the Graphical User Interface design. The proponents designed the software as a user-friendly system. The placement of the data was located where the user will have an easy access, and the idea was comprised to minimize the space needed for a certain data. Figure 4.13 shows the user login window. Upon opening the software application, login window will be the first one to be seen. This login requires username and password. If the user is not yet registered, click the Sign Up button. Figure 4.14 is the Sign Up window. In Sign Up window, the software only requires the user's name and user's preferred password. After the information was registered, the user can now log in into the system. Figure 4.15 shows the user profile panel where the user's name was located. It also comes with a Sign Out button where the personnel can sign out his account once he was finished doing the maintenance. This user profile panel was located on the upper left side of the window. Figure 4.16 shows the Add Motor button. Once the user was logged in, the system will allow you to select a motor if there is an existing one. But if there is not, you can add a motor into the system by clicking the Add Motor button on the lower left part of the window. Figure 4.17 is the motor registration window. In motor registration window, the user can now register a motor that was present in the company. The basic information like motor type, motor name, motor code, manufacturer, model, date of purchase, date of installation, and date of operation was needed to fill up located on the left side of the window. Another filling up in the right side is for the nameplate of the motor, basically its voltage, current, frequency, and phase. Next to it is the notification and alert settings, which enables the system to notify the personnel when will the maintenance proper should be done. After filling up, the user can now add the motor into the system. The three buttons in figure 4.18 shows the add motor, edit, and delete button. The add motor button allows the user to register motors into the system as illustrated in figure 4.17. The edit button enables the user to alter the information that has been registered, while the delete button allows the user to delete the information of a certain motor in the system. Figure 4.19 is the motor selection panel. Motor selection panel shows the three classification of electric motors, namely AC motors, DC motors, and other motors. In this panel, motor code text box and select button is also located. In motor code text box, the user may type the code of the motor for easier access, and when the motor has been typed, clicking select button will display its profile and maintenance modules. Figure 4.20 shows the AC motor, Figure 4.21 shows the DC motor, while Figure 4.22 shows the other motors. For AC motors, we have the induction and synchronous motor type, while DC motors divided into DC shunt, separately excited, series, PMDC, and compound type of motors. Moreover, for the other motors classification, we have the stepper and servo motor. The user may select the motor needed to be maintained by clicking the type of motor located on the motor selection panel on the left side of the window. Figure 4.23 shows the Profile tab. By just clicking the Select button on the upper left part of the window, located on the motor selection panel, the profile of this motor will be displayed under the Profile tab located at the middle part of the window. This profile of the motor was the information being filled up on the Add Motor button, which has been already registered into the system. Figure 4.24 shows the History tab. For the History tab, the user may select the period of the date where the history of all maintenance was done. The checkbox beside each maintenance type pertains to what type of maintenance will the user wants to view. Figure 4.25 shows the history records. Once the user clicks the view, a PDF file will flash into the selected area allotted for viewing the maintenance history of motors. This file was intended to be a PDF file for the user to be able to print it out. In this record, the personnel who did the maintenance and the date when the maintenance was done were included. Figure 4.26 shows the Scheduled Maintenance tab pertaining to preventive maintenance. Next to the History tab was the Scheduled Maintenance tab. This tab has also a tab under it which is the classification of the scheduled maintenance, namely Preventive and Predictive Maintenance. In Preventive Maintenance tab, the user will see all the scheduled maintenance on the selected motor, the daily, weekly, monthly, semi-annual, and annual schedule of maintenance. In this tab, the user may also print out the manual as a guide of what he will need to do for that specific motor. After doing so, the system will be updated by checking the corresponding action that the user did on the motor for the recording purposes. While Figure 4.27 also shows the Scheduled Maintenance tab which pertains to the Predictive Maintenance. The next tab aside from the Preventive is the Predictive Maintenance. In this tab, the manual for the predictive maintenance of a certain motor was located. It was also scheduled the same as preventive maintenance. The user may also print it out and update the system of what corresponding action was done by checking the corresponding checkbox in each maintenance. Figure 4.28 shows the Troubleshoot tab pertaining to the Manual tab. For the Troubleshoot tab, a Manual tab and an Update tab were located. For Manual tab, the user may see all the type of troubles that may happen into the selected motor. In Figure 4.29, it shows the motor's manual for troubleshooting. Once the user clicks the View button for the selected trouble, the system will display the PDF file of the manual for that particular trouble. This manual could be printed out as a guide for the personnel before doing the troubleshoot. Figure 4.30 shows the Troubleshoot tab pertaining to the Update tab. Next to the Manual tab is the Update tab. This Update tab is only intended for the updates of the troubles in a certain motor. Once the user was done on troubleshooting, he must update the system of the following information: type of failure, cause, date of failure, and the date fixed. A respective comment box was created for the corrective action done by the personnel to be filled up. Completing all the information allows the user to update the system. Figure 4.31 shows the history of maintenance. After updating the corrective maintenance or the troubleshoot, the user may check the history about corrective maintenance if the system already recorded and encoded the informations. Figure 4.32 shows the alert panel. Figure 4.33 shows the due today panel, while Figure 4.34 shows the reminder panel. The alert, due today, and the reminder panel of the system serves as the notifications of the diagnostic software. The alert panel shows the notification of the daily maintenance and the other scheduled maintenance that was skipped from the previous day. Those alert notifications of maintenance will vanish once the user did the maintenance and update the system. The due today panel shows the notification that was scheduled on that particular date. Once the user was done on the maintenance and updated the system, the notification will vanish and will no longer be displayed on the alert panel on the next day. On the other hand, the reminder panel shows the task notification that is needed to be done on the following day. Figure 4.35 shows the database design. Motor profile contains motor information that are displayed in the Profile tab. This table also includes dates when the motor maintenance checklist was last updated. Program Users table contains usernames and passwords. This table is used for login and sign up. Tables for notification contains the motor code and dates for reminder, due today, and alert. These are used for displaying reminder, due today, and alert notifications. Tables for checklist, on the other hand, contains the maintenance checklist inputted by the user. These tables are used to display the maintenance history of each motor. Lastly, Motor Troubleshoot table contains the information about the failures and troubleshoot of motors. This table is also used when displaying motor history.
The algorithm used in the development of diagnostic software is decision tree. Using this algorithm, if the motor that is subjected to maintenance program of the diagnostic tool experience malfunctions, the software has the possible causes of failure. Once the failure is identified, it will be followed by its corresponding action plan that serves as solution to the problem or failure being encountered.
Next is the software testing. This section discusses the testing of the software application. Due to the coronavirus pandemic, the testing will only include the functionality test since the performance testing could not be done by the proponents on the beneficiary because of the declared Enhanced Community Quarantine or ECQ. Functionality testing is the testing that verifies that each function of the software application operates smoothly. First is the AC motor maintenance test. In this test, the functionality of system's notification and update in AC motor maintenance will be tested. Figure 4.37.1 shows the registration of the AC motor into the system. All the information such as basic data, nameplate, and notifications and alerts are all filled up. The notifications for AC motor maintenance were discussed in the following. First is the daily. The user can enable or disable this notification since it was scheduled daily, meaning this maintenance should be done every day. Next is weekly. The user may select from Monday up to Sunday when will the maintenance must be done. Third is the semi-annually. The user will select when will the semi-annual maintenance will be started in order for the maintenance to set the date depending on what the user wants to schedule the maintenance. Third is the semi-annually. The user will select when will the semi-annual maintenance will be started in order for the system to set the date depending on what the user wants to schedule the maintenance. Last is the annually. The user will also select the specific date of the start of annual maintenance for the system to analyze and record the data. After filling up, Add button must be selected for the input motor to be recorded on the system. Figure 4.37.2 is the selecting of the AC type of motor. The user selected the AC motor on the motor selection panel, which was registered as shown in Figure 4.37.1. Figure 4.37.3 is the alert notification for daily preventive maintenance. Upon selecting the type of motor, there is an alert notification found in the alert panel for the daily maintenance of an AC motor. This notification will vanish if the user was done doing the maintenance and updated the system. In this figure, the user checked the checkbox for updating. Figure 4.37.4 is about the updating of the daily preventive maintenance of AC motor. By clicking the update button, there is a confirmation message if the user wants to update the maintenance. Waiting a few seconds, the daily maintenance on the alert panel was gone. Also, beside the update button under Preventive tab, the last update date was recorded. Figure 4.37.5 shows when did the user schedule the weekly maintenance. This could be seen under the Profile tab. Since the user scheduled it on Monday, the user will manipulate the date of the computer used to identify whether the weekly maintenance will appear on the notification or not. Figure 4.37.6 is the reminder notification for the weekly maintenance. Setting the date on Sunday, the day before the scheduled maintenance, a notification appears at the reminder panel. This reminder panel helps the user to notify that there is a scheduled maintenance needed to be done on the following day. Figure 4.37.7 is the due today notification for the weekly maintenance. Changing the date of the computer to the date of the scheduled weekly maintenance, which is Monday, the notification appears at the due today panel. The due today panel notification will vanish if the user was done updating this maintenance. Figure 4.37.8 is the alert notification for the weekly maintenance. If ever the user forgot to do the maintenance, the notification will appear on the alert panel. This alert notification will also vanish if the user updates the maintenance of the motor on that day. On the other hand, if the user updated the scheduled weekly maintenance on the scheduled date, the notification will no longer appear on the alert panel on the next day. Figure 4.37.9 is the updating of the weekly preventive maintenance of AC motor. In updating the weekly preventive maintenance, the user checked the checkbox of the corresponding maintenance that was done. When the update button was clicked, after a few seconds, the due today notification for weekly maintenance vanished. Also, the last update beside the update button has a corresponding date of action done. Figure 4.37.10 is the reminder notification for the semi-annual maintenance. For the scheduled semi-annual preventive maintenance, the user may see the scheduled date at the Profile tab. Manipulating the date of the computer, which is set to the day before the scheduled maintenance, a reminder notification appears for the semi-annual maintenance. Figure 4.37.11 is the due today notification for the semi-annual maintenance. Setting the date at the day of the scheduled semi-annual maintenance, the notification will appear at the due today panel. In the due today panel, there are two scheduled maintenance, the preventive and predictive. This is because the scheduled maintenance on AC motors for predictive has the same schedule for the preventive. The notifications were doubled because if ever the user forgot to do the predictive maintenance on that day, it will still appear on the alert notification. Figure 4.37.12 is the alert notification for the semi-annual maintenance. If the user forgot to do the semi-annual maintenance, the notification will appear on the alert panel. After doing the maintenance, the notification will be vanished. Figure 4.37.13 is the updating of the semi-annual preventive maintenance of AC motor. In updating the semi-annual preventive maintenance, the user checked the checkbox of the corresponding maintenance that was done. When the update button was clicked, after a few seconds, the due today notification for semi-annual preventive maintenance vanished. Also, the last update beside the update button has a corresponding date of action done. Figure 4.37.14 is the updating of the semi-annual predictive maintenance of AC motor. Same action was done in the predictive maintenance where the user checked the checkbox and update the system. The due today notification for semi-annual predictive maintenance also vanished. Figure 4.37.15 is the reminder notification for the annual maintenance. As the computer used was set to the day before the scheduled annual maintenance, the reminder notification appears on the reminder panel. Figure 4.37.16 is the due today notification for annual maintenance. When the user set the date on the scheduled day, the due today notification for annual maintenance appears. Figure 4.37.17 is the alert notification for annual maintenance. If the user did not able to do the maintenance on the scheduled day, setting the date of the computer on the next day, the notification for the annual maintenance appears at the alert panel. Figure 4.37.18 is the updating of the annual preventive maintenance for AC motor. When the user updated the scheduled annual preventive maintenance on the scheduled date, the due today notification vanished. Figure 4.37.19 is the motor troubleshooting for AC motor. In motor troubleshooting, the user can browse and print the provided manual located on the manual tab as guideline for doing the troubleshoot. Figure 4.37.20 is the troubleshoot update for AC motor. For the troubleshooting of AC motor, the user click the troubleshoot tab and then the update tab. The user fill up all the information done on the troubleshoot and updated the system. Figure 4.37.21 is showing the history of all the maintenance. In showing the history of all the maintenance done, the user clicked on the History tab. Setting the period of the maintenance done and checking the corresponding maintenance that the user wants to see, the View button will show all the maintenance. Those recorded maintenance comes with the date and the personnel who did the maintenance. Also, each page of the history has its title block which distinguish the maintenance according to the type of maintenance, type of motor, and the period. Second test is the DC motor maintenance test. In this test, the functionality of the system's notification and update in DC motor maintenance will be tested. Figure 4.38.1 shows the registration of the DC motor into the system. All the information such as basic data, nameplate, and notifications and alerts are all filled up. The notifications for DC motor maintenance were discussed in the following. First is the monthly. The user will set the date when will the monthly maintenance will start. With this setup, the system will be able to register the data which will be followed for the next dates of maintenance. Second is the quarterly. The user may also select a specific date of the start of quarterly maintenance. The system was intended to display the notifications every after 3 months. Last is a semi-annually. The user will select when will the semi-annual maintenance will be started in order for the system to set the date depending on what the user wants to schedule the maintenance. After filling up, Add button must be selected for the input motor to be recorded on the system. Figure 4.38.2 is the selecting of the DC type of motor. The user selected the DC motor on the motor selection panel, which was registered in Figure 4.38.1. Figure 4.38.3 is the reminder notification for the monthly maintenance. Upon selecting the type of motor, the user set the date of computer to the day before the scheduled monthly maintenance. There is a reminder notification found in the reminder panel for the monthly maintenance of a DC motor. Figure 4.38.4 is the due to day notification for monthly maintenance. Changing the date of the computer to the date of the scheduled monthly maintenance, the notification appears at the due today panel. The notification was divided into two, the preventive and the predictive maintenance, since monthly maintenance was done on both types of maintenance. The due today panel notification will vanish if the user was done updating this maintenance. Figure 4.38.5 is the alert notification for monthly maintenance. If ever the user forgot to do the maintenance, the notification will appear on the alert panel. This alert notification will also vanish if the user updates the maintenance of the motor on that day. On the other hand, if the user updated the scheduled monthly maintenance on the scheduled date, the notification will no longer appear in the alert panel on the next day. Figure 4.38.6. It is the updating of the monthly preventive maintenance for DC motor. In updating the monthly preventive maintenance, the user checked the checkbox of the corresponding maintenance that was done. When the update button was clicked, after a few seconds, the due today notification for monthly preventive maintenance was vanished. Also, the last update beside the update button has a corresponding date of action done. Figure 4.38.7. It is the updating of the monthly predictive maintenance for DC motor. Same action was done in the predictive maintenance, where the user checked the checkbox and update the system. The due today notification for monthly predictive maintenance also vanished. Figure 4.38.8 is the reminder notification for the quarterly maintenance. Setting the date on the day before the maintenance, a notification appears at the reminder panel. This reminder panel helps the user to notify that there is a scheduled maintenance needed to be done on the following day. Figure 4.38.9 is the due today notification for quarterly maintenance. Changing the date of the computer to the date of the scheduled quarterly maintenance, the notification appears at the due today panel. The due today panel notification will vanish if the user was done updating this maintenance. Figure 4.38.10 is the alert notification for quarterly maintenance. If ever the user forgot to do the maintenance, the notification will appear in this panel. The alert notification will also vanish if the user updates the maintenance of the motor on that day. On the other hand, if the user updated the scheduled quarterly maintenance on the scheduled date, the notification will no longer appear in the alert panel on the next day. Figure 4.38.11 is about the updating of the quarterly predictive maintenance for DC motor. In updating the quarterly predictive maintenance, the user checked the checkbox of the corresponding maintenance that was done. When the update button was clicked, after a few seconds, the due today notification for quarterly maintenance was vanished. Also, the last update beside the update button has a corresponding date of action done. Figure 4.38.12 is the updating of the quarterly preventive maintenance for DC motor. Same action was done on the preventive maintenance, where the user checked the checkbox and updated the system. The due today notification for quarterly preventive maintenance also vanished. Figure 4.38.13 is the reminder notification for semi-annual maintenance. For the scheduled semi-annual preventive maintenance, the user may see the scheduled date at the Profile tab. Manipulating the date of the computer, which is set to the day before the scheduled maintenance, a reminder notification appears for the semi-annual maintenance. Figure 4.38.14 is the due today notification for the semi-annual maintenance. Setting the date at the day of the scheduled semi-annual maintenance, the notification will appear at the due today panel. In due today panel, the two scheduled maintenance, preventive and predictive, are seen. This is because the scheduled maintenance on DC motors for predictive has the same schedule for the preventive. The notifications were doubled because if ever the user forgot to do either of the two maintenance on that day, it will still appear on the alert panel. Figure 4.38.15 is the alert notification for the semi-annual maintenance. If the user forgot to do the semi-annual maintenance, the notification will appear on the alert panel. After doing the maintenance, the notification will be vanished. Figure 4.38.16 is updating of the semi-annual preventive maintenance of DC motor. In updating the semi-annual preventive maintenance, the user checked the checkbox of the corresponding maintenance that was done. When the update button was clicked, the due to day notification for semi-annual preventive maintenance was vanished. Also, the last update beside the update button has a corresponding date of action done. Figure 4.38.17 is the updating of the semi-annual predictive maintenance. Same action was done in the predictive maintenance where the user checked the checkbox and update the system. The due to day notification for semi-annual predictive maintenance also vanished. Figure 4.38.18 is the motor troubleshooting for the DC motor. In motor troubleshooting, the user can browse and print the provided manual located on the Manual tab as guideline for doing the troubleshoot. Figure 4.38.19 is the troubleshoot update for the DC motor. For updating the troubleshoot, the user click the Update tab. The user fill up all the informations done on the troubleshoot and updated the system. Figure 4.38.20 is the showing of the history of all the maintenance. In showing the history of all the maintenance done, the user clicked on the History tab. Setting the period of the maintenance done and checking the corresponding maintenance that the user wants to see, the View button will show all the maintenance. Those recorded maintenance comes with the date and the personnel who did the maintenance. Also, each page of the history has its title block which distinguish the maintenance according to the type of maintenance, type of motor, and the period. The history could also be printed. Moreover, in the history of the troubleshooting, there is a frequency as can be seen in figure 4.38.20. This frequency pertains to how many times did the trouble occur and with what particular failure. Lastly is the other motor maintenance test. In this test, the functionality of systems notification and update in other motor maintenance will be tested. Figure 4.39.1 shows the registration of the servo motor into the system which was located on the other motors. All the information such as basic data, nameplate, and notifications and alerts are all filled up. The notifications for other motor maintenance were discussed in the following. First, the daily. The user can enable or disable this notification since it was scheduled daily, meaning this maintenance should be done every day. Second is the weekly. The user may select from Monday up to Sunday when will the maintenance must be done. Third is the semi-annually. The user will select when will the semi-annual maintenance will be started in order for the system to set the date depending on what the user wants to schedule the maintenance. Last is the annually. The user will also select the specific date of the start of annual maintenance for the system to analyze and record the data. After filling up, Add button must be selected for the input motor to be recorded on the system. Figure 4.39.2 is the selecting of the servo type of motor. The user selected the other motor on the motor selection panel and choose the servo motor, which was registered in Figure 4.39.1. Figure 4.39.3 is the alert notification for the daily preventive maintenance. Upon selecting the type of motor, there is an alert notification found in the alert panel for the daily maintenance of other motor. This notification will vanish if the user was done doing the maintenance and updated the system. In this figure, the user checked the checkbox for updating. Figure 4.39.4 is the updating of the daily preventive maintenance for servo motor. By clicking the update button, there is a confirmation message if the user wants to update the maintenance. Waiting a few seconds, the daily maintenance on the alert panel was gone. Also, beside the update button under preventive maintenance, the last update date was recorded. Figure 4.39.5 is the weekly preventive maintenance schedule for the servo motor. The figure shows when did the user schedule the weekly maintenance. This could be seen under the Profile tab. Since the user scheduled it on Tuesday, the user will manipulate the date of the computer used to identify whether the weekly maintenance will appear on the notification or not.
Figure 4.39.6 is the reminder notification for weekly maintenance. A notification appears at the reminder panel. This reminder panel helps the user to notify that there is a scheduled maintenance needed to be done on the following day. Figure 4.39.7 is the due to day notification for the weekly maintenance. Changing the date of the computer to the date of the scheduled weekly maintenance, or the Tuesday, the notification appears at the due to day panel. The due to day panel notification will vanish if the user was done updating this maintenance. Figure 4.39.8 is the alert notification for the weekly maintenance. If ever the user forgot to do the maintenance, the notification will appear on the alert panel. This alert notification will also vanish if the user updates the maintenance of the motor on that day. On the other hand, if the user updated the scheduled weekly maintenance on the scheduled date, the notification will no longer appear on the alert panel on the next day. Figure 4.39.9 is the updating of the weekly preventive maintenance for servo motor. In updating the weekly preventive maintenance, the user checked the checkbox of the corresponding maintenance that was done. When the update button was clicked, after a few seconds, the due to day notification for weekly maintenance was vanished. Also, the last update beside the update button has a corresponding date of action done. Figure 4.39.10 is the reminder notification for semi-annual maintenance. For the scheduled semi-annual preventive maintenance, the user may see the scheduled date at the Profile tab. Manipulating the date of the computer, which is set to the day before the scheduled maintenance, a reminder notification appears for the semi-annual maintenance. Figure 4.39.11 is the due to day notification for semi-annual maintenance. Setting the date at the day of the scheduled semi-annual maintenance, the notification will appear at the due to day panel. In due to day panel, the two scheduled maintenance, preventive and predictive, are seen. This is because the scheduled maintenance on other motor for predictive has the same schedule for the preventive. The notifications were doubled because if ever the user forgot to do the predictive maintenance on that day, it will still appear on the alert notification. Figure 4.39.12 is the alert notification for semi-annual maintenance. If the user forgot to do the semi-annual maintenance, the notification will appear on the alert panel. After doing the maintenance, the notification will be vanished. Figure 4.39.13 is the updating of the semi-annual preventive maintenance for servo motor. In updating the semi-annual preventive maintenance, the user checked the checkbox of the corresponding maintenance that was done. When the update button was clicked, the due to day notification for semi-annual preventive maintenance was vanished. Also, the last update beside the update button has a corresponding date of action done. Figure 4.39.14 is the updating of the semi-annual predictive maintenance for servo motor. Same action was done in the predictive maintenance where the user checked the checkbox and update the system. The due to day notification for semi-annual predictive maintenance also vanished. Figure 4.39.15 is the reminder notification for the annual maintenance. As the computer used was set to the date before the scheduled annual maintenance, the reminder notification appears on the reminder panel. Figure 4.39.16 is the due to day notification for annual maintenance. When the user set the date on the scheduled day, the due to day notification for annual maintenance appears. Figure 4.39.17 is the alert notification for the annual maintenance. If the user didn't able to do the maintenance on the scheduled day, setting the date of the computer on the next day, the notification for annual maintenance appears at the alert panel. Figure 4.39.18 is the updating of the annual preventive maintenance for servo motor. When the user updated the scheduled annual preventive maintenance on the scheduled date, the due to date notification vanished. Figure 4.39.19 is the motor troubleshooting for servo motor. In motor troubleshooting, the user can browse and print the provided manual located on the Manual tab as guideline for doing the troubleshoot.
Figure 4.39.20 is the troubleshoot update for the servo motor. For the troubleshooting of servo motor, the user click the troubleshoot tab and the update tab. The user fill up all the informations done on the troubleshoot and updated the system. Figure 4.39.21 is the showing of the history of all the maintenance. In showing the history of all the maintenance done, the user click on the History tab. Setting the period of the maintenance done and checking the corresponding maintenance that the user wants to see, the View button will show all the maintenance. Those recorded maintenance comes with the date and the personnel who did the maintenance. Also, each page of the history has its title block which distinguish the maintenance according to the type of maintenance, type of motor, and the period. In history of the troubleshooting of all types of motors, there is a frequency. This frequency pertains to how many times did the trouble occur and with what particular failure.
Good day to everyone. I am Ryan J. Ramintilla and I will discuss the Chapter 5 of our research study. This includes the discussion of the findings, the conclusion, and the recommendation. For the summary of the findings, the researchers conducted preliminary profiling of the motors that are available at CAIC Feed Mill. Calao Agro-Industrial Corporation or CAIC Feed Mill was consist of 12 motors that are all in operations. All of these motors are inductive type and operate on a 3-phase power source at 220 volts and 60 Hz frequency. Highest power rating of the motor was 50 horsepower, which is the hammer mill and found in the grinding section. The remaining motors has the power rating ranges from 1.5 horsepower to 30 horsepower, which complete the full operation of the feed mill from mixing process up to the packaging process. All motors are manufactured by USA Lincoln Machine and was installed and subjected into operation of about year 1999. On the development of the diagnostic software as well as the maintenance program it will provide, the researchers consider different factors to create a reliable and effective maintenance program. First was the programming language that best suits the goal of the study, which is to provide maintenance program to electric motors. In line with this, the database and the GUI or the graphical user interface were put into considerations. Another important factor was the algorithm used in the diagnostic tool development. The researchers also give attention to the maintenance standards required for different types of electric motors. Then, the researchers identify the different factors that affect the operation of electric motors, which are categorized into electrical factors, mechanical factors, and environmental factors. Unfortunately, the researchers were not able to test the diagnostic software at Calao Agro-Industrial Corporation or CAIC Feed Mill, which is the beneficiary of the study, because of the community quarantine imposed by both local and national government. However, the researchers conduct several testing to measure the functionality of the diagnostic tool in terms of its response to the maintenance program it will provide, which includes preventive maintenance, predictive maintenance, and corrective maintenance. Now, let's proceed to the conclusion of the study. Based on the findings of the study, these are the conclusions made. First, all the motors at CAIC Feed Mill are alternating current motors and operates a 3-phase supply of 220 volts and frequency of 60 Hz. All are purchased, installed, and subjected into operation of about 20 years, and proper maintenance to the motors was not applied. Factors such as electrical factors, mechanical factors, and environmental factors greatly affects the operation of the motors. The motors operates at dusty environment which causes the low performance of the motors. Also, the ambient temperature of the feed mill contributes to some malfunction of the motors. Electrical factors also causes failure which includes the shortage of power supply in a way that the motors at CAIC feed mills requires high starting current to operate as well as the loss of electrical connection due to environmental factors. Different parameters are considered in the development of the software. All the data of the diagnostic tool was organized and saved into the database in which all the elements are interrelated to each other for the simulation of the commands. Algorithm used was decision tree, which means during the troubleshooting process, the diagnostic tool will provide the possible cause of the malfunction as well as the solution to this failure. The diagnostic tool was user-friendly in a way that the graphical user interface or the GUI used was understandable, displaying all the features of the diagnostic tool and can be executed easily. The software provides maintenance based on the standards provided by National Manufacturer Association or the NEMA and the Philippine Electrical Code or the PEC, which includes preventive, predictive, and corrective maintenance. The last part of the conclusion is about the testing of the diagnostic tool. All the features of the diagnostic software are working in accordance to its expected functions. The diagnostic tool can successfully provide maintenance program into the motor such as scheduled maintenance and troubleshooting in case of failure for both AC motors and DC motors, as well as the other types of motors. For the preventive and predictive maintenance, the software is capable of providing all the scheduled maintenance, which is the daily, weekly, monthly, quarterly, semi-annual, and the annual maintenance. When the electric motor experiences error or failure during the operation, the diagnostic software also provides corrective action and will troubleshoot the motor to identify the possible cause as well as the possible solution into the trouble. All the maintenance performed into the motor are kept into the diagnostic tool history and can be used again for future maintenance plan. In this case, all the records will be safe and can only be accessed by the authorized user. The maintenance plan of the software can be produced as printout copy to serve as guidelines while performing the maintenance into the motors. All the maintenance records of each motors can be printed out from the History tab once the user wants to review each of the maintenance for the preparation for the future maintenance plan of the company. The maintenance program embedded into the diagnostic tool is expected to improve the overall performance of the motor due to the scheduled maintenance and the corrective maintenance provided by the system. And for the possible future improvement of the research study, the researchers provide some recommendation. First, the researchers greatly recommend to the future researchers to continue the study for validation in a way that they will test it into company, especially to those companies operating with motors and needed such motor maintenance program. It is because that the researchers were not able to do such actual testing due to the pandemic experiencing across the globe. Next, the researchers recommend the study for the future researchers to add more features into the diagnostic software for better maintenance of electric motors. It can be motor sensors and other devices that will easily identify the failures of the electric motors. The researchers recommend the study for the future researchers that they could work collaboratively with any programming-related researchers since they are more knowledgeable in the field of programming. The diagnostic software should be bound in the internet so that the user can access the information of the software in case of emergency access. Lastly, the testing of the software should be done in a company that has a complete classification of motors from AC to DC and other types of motors. In that way, the researchers can identify the functionality, efficiency, and reliability of diagnostic software. This ends the chapter 5 of our project study.